So continuing on with our plan to finish off this robot, this video we're going to focus on assembling this arm mechanism here. You know, normally when you're designing something, you've got an idea of where it is you're headed, played with some prototype parts or have a whiteboard sketch. Here I'm just going to show you what the end result's going to be. So we're going to build a new assembly, and it'll be separate from the base assembly. So that's our plan. You can see we used a 10-hole high post. It's got a motor and it's got some sprockets and things. So that's kind of what we're going to build. So going back to our robot, we're going to start a new assembly. This is going to go way faster because a lot of this stuff you've already done. Our arm, in fact, we can actually look at just the arm assembly here. This is what it's going to look like. We have a deep channel. We have a quad block. There's another quad block up here that's going to help support the end of this shaft here so that we can attach that to the robot arm. We're just going to make note of the fact that that quad block is going to be aligned with this second hole. There's a shaft that we're going to need to import, make the post, and the post consists of quad block, a 10-hole GoBuilda U channel, and this another quad block. So going back over here, we've started our new assembly, and I'm going to right-click, rename it Arm Assembly. We are going to import some parts. So we're going to insert them from our library. We're going to use the 10-hole one here. Okay. And we need a couple of quad blocks. You are going to figure out the rest of that. And I'll leave this up here for a sec so that you can pause on it. A quad block at the bottom, see down there? Put that on, put the screws on. There's a quad block up here, and I'll leave it here while we pause for you to do this, and see if you can figure out how to get that to align like that. Go do that. Hopefully you ended up with something that looks a lot like this. Again, this is all stuff that we did in the previous videos. So the next thing that we're going to want to do is, if I look at that arm assembly, let's start with the motor down here. This is going to be very similar to something we've already done, so you're going to figure that out really quick. Couple little changes though. This is a different motor than the one that we used before, and I wanted to take this opportunity to show you some models, including our Yellow Jacket model, actually has some configuration options. So we're going to insert from our library an assembly, and we're going to do a Yellow Jacket motor. Now, before you click on that, take a look at this little spin down here, and you can see it has the ability to select gear ratios. And if I click down on this, there's a list of the gear ratios that GoBuilda offers, and I'm actually going to select the 188:1 gear ratio, and that is the motor that I would like to insert. So I'm going to click on this, and you can see that it is got a much bigger gear head on it. Configuration is adaptable later, so if I hover over my Yellow Jacket instance in the assembly, you can see the configuration options that were used to insert this one. I can right click it and do a change configuration is an option here, and it turns out I can change the gear ratio. Let's take it all the way down to a 3:1. And you can see that the length of the gear head is changing based on the parameters that were set up in all of these things. At a later time where I'm going to show you how you can do these as well for your own parts. For now, we'll put this guy back to 188:1 and leave it there. You're going to mount this through the second hole here and put screws in. This is like very similar to the first motor that we mounted. It's got the little oblong holes here, so you have to put the screws in and such. You should have something that looks very, very similar to this. If you're having issues mounting that motor, it's almost the exact same steps that we used at the beginning of video number 2, where we mounted the motor to the quad block. We now would like to add to that this sprocket assembly. So this sprocket assembly consists of a hub assembly that is in our library. We'll go grab that in a sec, and a sprocket, which is also in our assembly. Let's do a sub-assembly of this. Insert new tab, create assembly. And so we end up with assembly 1 here. I'm going to right click that and rename that to be mounted sprocket. And from our OSK23 library, the sprocket, which is down here, almost down to the bottom, there are 2 sprockets down there. Get the 3310-014, okay? So you want the one that looks like that. And from assemblies, grab the hub up here on the top. So we're going to click this 1309 and we'll plop that down right there. Okay. And as always, take the first part that I inserted into an assembly and I right click it and I fix it in place so that things move relative to it. Notice that the sprocket has through holes. Those are 4mm holes, and a 4mm screw will go right through it. And it has thread a screw into that hole. So ideally, we would like to align these threaded holes up with a non-threaded hole on the other part. My first inclination is to just try using a fastened mate between this part, and I'm gonna click on this outside edge out here and click there. So I was able to use the geometry of the part to get the center there. And I can click on this and those should fasten themselves, okay? And it looks like everything lined up pretty good, except it turns out that the threaded holes, if I do this and zoom in, you can see the threaded holes lined up and kind of isn't really what I wanted to do. There's a few things I could do to fix that. One thing I could do is if I go to edit this and I can do an offset, and I could rotate this this fastened mate by some number of degrees around z-axis. And so if I come down here, so I've hit offset, I'm going to click on rotate about z, and I need to enter the number of degrees. Well, I kind of want to move 1/8 of a turn, right? So, and it turns out to be, I think I need to rotate this thing about 45 degrees. So let me try that, 45 degrees. Okay, so I've rotated that about 45 degrees, and I can see in here that, oh yeah, look, that hole now pretty much aligns. So now I've got the proper alignment that I was looking for. My goal in doing that was to show you that if you click this offset, you can do various things. You can rotate about around various axes. You can rotate around one axis at a time, actually. You can offset from the mate connector along the z-axis. You can offset along the y-axis or the x-axis, right? So we just did a rotate there. So now it's a matter of just adding some screws. And so I'm going to do our standard measuring thing. So I'm going to look from there to here. Turns out to be about 18 millimeters. So let's insert some screws. Standard content button. We'll use button heads again. And I happen to know my toolbox doesn't have 18, so I'm going to use 16s. That works. And again, we want the screw is going to pass through here into the threaded part. So I want that hole, that hole, that hole, that hole. Insert. This completes this little assembly here. I'm going to hide all my mate connectors. Take a pause and go do that. So we now have that little gem, and we can go back to our Arm assembly, and we can insert from our current document a new assembly, and it's called mounted sprocket. Okay, and we'll throw that in here. Cool. And we'd like to mount it to this shaft here. I'd like the sprocket to be on this other side. I'm going to show you one more cool thing that you can do. This is one of those planned tangents. If I click on this part, see this fancy handle that showed up here? This is for manipulating the orientation of a part or an assembly. And it has lots of things you can grab hold of. These little squares here, if I grab one of those squares, I can drag the part around. This one with the arc on it allows me to rotate a part. So I can actually grab that and rotate, right, around one of the axes. And so I'm going to put that back to 0 because I'm going to make it not have done anything there. Okay, so I'm going to click on the left face. There we go. Now you can see if I rotate this around, what I really want to do is I want to kind of rotate this so it orients sort of properly. Okay, I did it 180 degrees. There we go. So I would now like to somehow get this guy to mount on there. Okay. And I kind of want to mount it in that orientation. One way I could do this, I also want it to rotate, by the way. So I could do a revolute mate. I'm going to slide this out of the way and the end of the shaft. So I want that. So I got the mate connector at the end of the shaft and this. Okay, there we go. Is this exactly what I want? No. Why? Well, remember the screws? We're going to conflict with the screws down here. It is really close to conflicting with the screws. I'm gonna say that we're gonna hit those screws. So let's think about this a little bit. Well, this part actually clamps onto this shaft, and so that means that it'll rotate, but I could also slide this thing right and left. And if you'll remember in our mating discussions before, a revolute will only rotate around the z-axis. There was another one. It was called a cylindrical. There it is. That cylindrical mate, if I change it to a cylindrical, it'll rotate, but we can also slide it. Okay. So that's what I'm going to do for right now. So this, I acknowledge that this part is a little bit loose at the moment, and we'll end up fixing it in a different way a little bit later. Okay. So there we go. Go do that. Let's take a look at our diagram up here at the top. We're thinking about putting a shaft through here, and you can see we're going to have to add a couple of bearings, and we have to add this shaft, and then some other stuff will attach to it. So we're really kind of focused just on the shaft and the bearings. These will just add directly to the arm assembly. First step is let's go insert the bearings. So I'm going to go to other documents. There's our OSK library. These are composite parts. The bearings are composite parts. So I'm going to click here and we're going to scroll down. Now, but if you'll remember before, we used the first two bearings here and they end in 3 zeros and a 6. And those are smooth bore. It turns out that there's another one here. It has a hex. This is a hex bore and it has a 4008 at the end. So we need 2 of those. Pop one of those there. Pop one of those over there. Okay, that's pretty straightforward. If you remember, when we use flanged bushings, we like to mate to that surface right there, and you're going to mate that to this surface here because it's going to that bearing is actually going to fit just barely inside this hole, and so you want to mate that, fasten mate that to here. And you're going to do the same thing on the other side. You're going to take that the other bearing and fasten mate the flange to here. Go ahead and go do that now. You should have ended up with a bearing that has fit into that 14 millimeter hole. It was the second hole down, by the way. And across this side, you have another bearing that actually sort of fit into this this countersink here, and it should look like that. All right. So now we would like to go find ourselves a shaft. We know that this from here to here is 48 millimeters because we've measured that before. And if I didn't know that, and if I couldn't remember that, I could actually just come up here and click on that line. It'll tell me it's 48 millimeters. Okay, that makes sense. I honestly don't remember how long this part is, so I can also measure from here, from that plane out to this plane. It tells me it's 28 millimeters. Okay, that's rational. So 28 plus 48, 76 millimeters. And then there's a little bit more sticking out over here. So I think this is actually an 80 millimeter shaft. We don't have one of those, by the way. If you go look in the library, one isn't there. And that's because you and I are about to import our first part. We are going to go to the manufacturer's website and we're going to go find ourselves a step file. Let's go figure all this out right now. A new tab in my browser. We're going to go to GoBuilda. Okay. So here's GoBuilda, and it turns out Andy, Mark, Rev, all of the First Robotics folks are pretty good about putting out CAD files. We need to find a shaft, and I can search for it. I can say I think it's called a Rex shaft, aluminum Rex shafting. Actually, I'm going to go use one of these that have the little clip on it, just because it'll make our life a little bit easier, okay? And so they have a whole bunch of them here. And so we need to pick one. We think we wanted an 80 millimeter one. Here it is here. So if I click on that, there's an 80 millimeter one, and it'll show you a little diagram of what everything looks like. See how they used a cross section. Remember, we had cross sections in our in the view cube. So there's a cross section of the part. It's showing you the thread depths and such. It's also showing you that there is a E-clip out here on the end. Okay, so this is actually an assembly. Okay, and if I look down here, I can find a thing to download. It's called a step file, and step files are sort of the standard language of CAD programs. All CAD programs can import step files. It's the lowest common denominator file, but it's the standard, and a lot of people end up using these. Okay, so I'm going to click on the step file, and this is going, and it's downloaded it. See it here? So I'm going to open that file. It's a zip file. I need to extract this file from the zip file. GoBuilda tends to send you zip files, and they need to be extracted. So in Windows, I can just hit extract all. It's asking me where to put it. I'm going to close the zip file now. Here is that thing. It's called a step file. I'm going to move this out of the way for now, and we're going to go back to, so I now have a file sitting on my computer that I downloaded, and I would now like to import that into my document here. So I'm going to come over here. I'm going to hit Insert New Tab, and I can import a file. Okay, and for me, everything always ends up in my downloads directory. So if you go to your downloads directory, look for the newest thing that you downloaded, and it's going to be not in the zip file, but you want the extracted file and this assembly file. Okay, so some options are going to appear here, and so we need to talk about those. So I'm going to upload that. Now this dialog is asking me, do I want to import this document or combine into a single part studio and use this with small assemblies? Unless you know for a fact that you want to import a full assembly, I would pretty much always choose combine into a single part. We know that this has two parts in it. I'm actually going to create a composite out of it. So I'm going to create composite part when importing multiple or non-solid bodies. If you're not sure, you can actually change this later. Okay, so we're going to do an import of that. And so what's happening is it's uploading from my computer to Onshape, and it's going to import it, and then it's going to translate it into a part studio. So we'll watch down here. It should show up here any second. There it is. So you can see it's imported this thing as a part studio, and it translated successfully. So that's good. So I'm going to close this little window, and we can go look at this thing. It is so that's how I import parts using step files. And again, you can import step files from almost any source. We'll be doing a lot of that sort of stuff later, but I just wanted to show you that's how you grab one. Quick tour. The parts are listed over here in a part studio. This is not an assembly. See, all of this is different. We are going to change a few things though. See where it says composite parts? That's where I imported a composite part. And so I'm highlighting it there. I can right click it and assign a material to it. And it turns out that this is made out of stainless steel. So, material, Onshape material library is usually the one that you would normally use. And then in the search by material, you can start typing in stainless, and 300 series stainless steel is probably about right. And this will assign its material so that it knows its mass, how heavy it is and so forth. Okay, so I'm going to hit the green check mark there. Now the other thing I can do is I can right click it and edit its appearance. And because right now it's a funny yellow color. For stainless steel, I usually use a slightly yellowish color of steel. So maybe this one here. Yeah, that looks good. It'll help you distinguish it from aluminum. So now if I scroll in on this thing and I can rotate around, standard mouse controls, it kind of looks like a stainless steel part. So there we go. We just inserted a part that we didn't have before. Okay. You can see it's in Part Studio. It also created this CAD imports And this actually is the step file itself. You can generally ignore the CAD imports directory, just leave it alone. The program needs that file to recreate this thing. Now we're going back to our Arm assembly, and we can insert from current document. And look, we now have a part studio. The fact that there are two entries for this is a little more complicated. We'll talk about that a little bit later. So I'm going to spin that up. We can insert that, ended up with that shaft. We're good to go. All right. What did we just do? We just went out, found a part that we needed, imported it, brought it into our file here. Life's good. We would actually like to put that in the model here. Now remember that this is fixed. That bearing there is fixed. This thing, we're going to want it to be able to rotate. So I'm going to put in a revolute mate. As I scroll in on this, I actually want, so the surface of the E-clip, and I'm going to click there. So I've grabbed the center of that surface. Okay? And we're going to want that to ride on the surface of this bearing here. And I'm going to select that. Okay, so there we go. And if I hit the green check mark, I should now have that shaft running through that bearing. Hey, I'm going to right click this and I'm going to fix the main post there because we're going to start dragging stuff around. But you can see this shaft can spin. We want that shaft to spin. That was a lot of steps. You got it. If you need to, you can come rewind. Go do that right now. Okay, welcome back. So, hey, let's take a look at where we are right now. We have that shaft is inserted there, and now we want to add a sprocket assembly for the top. So let's have a look at that real quick. There's a sprocket assembly up here. It's got one of those hubs and a sprocket and 4 screws. Let's ignore the arm part of it just for now because we'll deal with that later. So, hey, let's do another assembly. So I'm going to go back over here. Let's start a new assembly. Right-click, rename, large, mounted sprocket. Insert from, okay, so assemblies, we want one of those. Cool. And then from the part studio, there's a large sprocket all the way down at the bottom. So we want the 28 tooth sprocket. We'll pop that right there. We should be able to just do a fastened mate. Pick that. Okay, that looks good. We should be happy there. Go add 10 millimeter screws. 1, 2, 3, 4. You know how to do that. Go do that and I'll wait for you. Hopefully you've got something that looks a lot like this. Let's go back to our arm assembly and let's insert that. So insert current document, assemblies, large mounted sprocket. There it is. Okay, now much like the previous sprocket down here, we need to mount it to this shaft. Now, one of the things that I had to think through is where's the chain going to go? And so chain has a thickness to it. Specifically, I need the chain. I need some space on both sides for the chain. So that tells me that the hub is actually going to be on the outside this time where it was on the inside last time. We're going to make sure that we're doing that, all right? So let's go back over here. So it is going to sit oriented just like that. And I believe I would like to do another cylindrical mate. Oh, no, I don't want a cylindrical mate, do I? I don't want this to rotate. Let's think about that for a sec. Actually, I want it to be able to slide back and forth on this, but I want this actually to be fixed to the shaft, okay? We want that attached to the shaft. So rather than a cylindrical mate, I think I'm actually going to use a slider mate, okay? And I was just thinking about the degrees of freedom I want. And I don't want this thing to rotate on the shaft, but I want it to be able to slide on the shaft. So let's try that. I'm going to click on there. And we're going to go click on there. Okay. That looks about right. And so now, when I turn this, you can see it rotating there. That's what I wanted. All right. Okay. So this slides. Right? but it also will rotate with the shaft, which is exactly what we want. All right, very good. So next thing we need to add is an arm. And the arm is going to attach to this. So let's go insert an arm. Insert. Current document. No, we want to go to our library again. And this time we're going to use an 1121 part. It's a long, skinny fellow. Looks like that. Okay. It's a U channel, but it's kind of skinny. And I'd like to attach to this hole right here. Okay. And I would like that to attach here. I don't want it to revolve in relation to this. It's going to be fixed. So we're going to do a fixed fasten to meet between this and this. Did that make sense? And apparently I did not do the right thing on that second connection. Let's try that again. I need it to be this. There it is. All right. So now I need to fasten it. Oh, so there's an issue. Yeah, you know, when you're assembling stuff, you sometimes run into things. Check this out. Those screws. Those screws are, I can't use those screw holes. Well, that's a hassle. You know, this is actually pretty thick over here. I think we use 10mm screws there. I could use a shorter screw. If I change this to a 6mm, and I can measure the distance from here to here is 13mm. Okay, so if I change these to 6mm and then put 6mm in from the other side, that'll be plenty to hold it, and I can use the same screw holes. Okay. So how am I going to change those? Well, turns out if I come back up here, I think the last 4 button head screws, oh no, those button head screws are something else. I need to go back to my assembly, to that large sprocket assembly here, and take these screws, and I need to change their length. And it turns out that these are configured parts. So if I right click over here, I can edit standard content instance. See that little thing there? Allows me to change some parts of the screws. And so, for example, I can now change these to be 6mm screws. All right. And if I do an update, you can see that the screws no longer go all the way through. So now if I go back to that arm assembly and I come around and I look, I can see that, oh, you can see the end of the 6mm screw is in there. All right. So my purpose of showing you that was, hey, look, you can actually go edit you can do things like edit the length of a screw as things pop up. Go do that now. You should have something that looks like that. You've got a couple of screws going in there, and yeah, a couple of side tangents here real quick. If I click on this part, I know I've got these 2 screws going in there. If you'll remember, we can make this thing transparent. And now you can actually look at there. You can see, okay, the screws are not hitting, right? You can see the other screws. Those screws are in the clamp, but you can see that our 2 6mm screws have about a millimeter gap there. So that's pretty cool. Another thing I just wanted to show you, so that was the make transparent. You can also right click and isolate. If I wanted to look at just the hub, right, that isolates just the hub. So if you need to go in and take a peek at just a specific part, there you go. Let's talk about sprockets here for a sec. Chain and sprockets. The sprockets need to be on the same plane. This is an opportunity for us to use a planar mate. So in just a second, you are going to do the following things. You are going to click on planar mate, and you're going to click on the outside of that sprocket. Highlight like that. Come down here, and I'm going to click on this sprocket. Now, don't be alarmed that that moved. It's just showing you that those are now planar. And because when you hit solve, it'll resolve the assembly and put everything back. But it's telling you that those are now on a plane. Awesome sauce. So you can hit a green check mark on that. What did that do for us? I'm going to close the planar mate there. These are now always on the same plane. So if I move these, the other one will move with it. And I'm going to move these out of the way for a sec. When you look at spring clip over here, this prevented from going to the right, okay? But it can go to the left because the spring clip is not actually an attachment. So that means that I could, if this was in reality, come push on this end and slide that thing right out. I'm pointing that out because when we go and attach this and we clamp, when we clamp this hub to that, nothing will prevent this thing from moving in. It won't be able to, it'll only be able to travel to the right so far because of this clip over here, but nothing is preventing it from this shaft from pushing all the way over to the left there. All right, so we're going to need to put in a spacer on that side. We can actually make a 3D printed spacer, which is going to allow us to do some stuff in a part studio. So that is going to be a project that we're going to come up with here in just a minute. I am, however, going to bring this over. When I look down here, I'd like the hub to be close, but not touching those screws there. So that's probably a good spot for it, right about there. I'm actually going to just leave that there for a sec. We are going to patch that up when we get to doing part studios in the next video. On the end of this arm, remember we put a slider mate on this? I'm actually going to make this into a fastened mate just for now. All right, so that's a fastened mate so that this thing will stay put so we can manipulate it. Notice that the planar mate still works down here, but now since this is fastened up here, this no longer moves. That's what I did, is I just changed this slider mate so that this thing no longer moves. In reality, you have to watch out for that because, again, we need to put a spacer between there and there. So go do that right now. We're now going to throw a motor on the end of this thing. We will eventually attach a gripper to this. Back to this side, insert, standard content, other documents, assemblies, and one of these is a mounted servo motor. Okay, won't get into, servo motors are very cool. They're very compact. They're usually pretty strong. You can put them in two modes. One will allow them to continuously rotate. The other will allow it to move to a specific position. And so they're kind of a staple of the robotics world. All right, so we're going to attach it here. This face is going to get screwed on here, so it's going to be a fastened mate. So we're going to do a fastened mate between the inside of that. See, I grabbed the inside instead of the outside. And the center of this. Okay, and it moved. That's all right. We know if we hit the solve button, it'll go up there, and I will hit the green check mark, and there it is. So here's what I want you to do. I want you to go and I want you to measure how long the screw needs to be. It needs to be from here to there. You know how to do that. And then insert screws, 1, 2, 3, and 4. Go do that and come back. All right, so you should have ended up with something that looks a lot like this. We have an arm that has a servo motor on the end of it that we'll be able to attach some things to. One last thing that we want to do is, or we can do, is we could establish a relationship, a gear relationship between this gear and this gear. Okay, so how are we going to do that? Well, it turns out that if we do a gear relation, and we would like to use a revolute mate. Well, we don't have any revolute mates here, but we do have one over here. So let's go find, I believe it's that revolute mate there. And then it turns out there's another revolute mate. It's down here and attaches the this guy, but it's actually a cylindrical mate. It's this one here. So we should be able to do a cylindrical mate. Cool. It turns out this is a 14 tooth. This is a 28 tooth. So the gear relationship should be a 2-to-1. Okay. And so that means, let's see, that means what? For every turn of this one, okay, here we go, let's do this. Okay, so now, as I turn this guy, The bottom one should be going faster than the top one. So let's try it. Okay. So if I turn this guy by a quarter, see how the top one is slower than the bottom one? So it takes a half turn here, results in a quarter turn up above, and that's what we wanted. So I know that there's supposed to be chain in there. Chain's complicated, not a beginner topic. So we'll deal with that later. All right. This arm is now ready to go. So go do that. Hopefully that's working. We're now going to mount the arm to the robot. Okay. So we have this arm assembly. Here's the robot. I would now like to insert from the current document, the assembly, arm assembly. Okay. Cool. Now we're going to mate the thing. And as I recall, if you'll recall from the example, we sort of lined up on the cross member. We're using the third hole over here, fastened mate on the third big hole on the back cross member. Okay, and I would like to mate that to the large hole in the bottom of the. Okay, so you should now have a robot base that looks a lot like this. You've seen how to assemble things. You've seen how mates work. You've seen some of the specialized mates, the ones that driving things. You've learned about screws. You've seen a whole bunch of different ways of looking at things and navigating around stuff, making things transparent. And this is actually a robot frame that is being used in a contest. Next up, we're going to start doing part studios. That'll involve doing some drawings, extruding parts and making things that you'd be able to 3D print or otherwise make custom parts out of.